The limit as x approaches 0 of cosine x minus 1 over x is a well-known limit which equals 0, and what we're going to be doing is proving this result without using L'Hopital's rule. This proof uses another well-known limit, which is the limit as x approaches 0 of sine of x over x, which I already did a video on, which I will link in the description. The reason we can't use L'Hopital's rule is because to apply L'Hopital's rule, we would need to already know the derivative of cosine of x, and it turns out that to find the derivative of cosine of x using the limit definition of the derivative, we would need to know the limit as x approaches 0 of cosine of x minus 1 all over x. So here's what we do. We first multiply the entire expression in the limit by cosine x plus 1 over cosine x plus 1. If we combine the two fractions, cosine x minus 1 times cosine x plus 1 is just cosine squared of x minus 1 squared, which is the same as cosine squared of x minus 1, and the denominator becomes x times parentheses cosine x plus 1. I'm not going to expand out the expression in the denominator, and you'll see why in a second. We can also rewrite the numerator as negative parentheses 1 minus cosine squared of x. The next thing to do is to rewrite the numerator using an identity. Consider the Pythagorean identity sine squared of x plus cosine squared of x equals 1. If we subtract cosine squared of x on both sides, we get the identity 1 minus cosine squared of x equals sine squared of x. If we use this identity, the numerator goes from negative parentheses 1 minus cosine squared of x to negative sine squared of x. We can split this fraction into the product between sine of x over x and negative sine of x over cosine x plus 1, which is why we didn't want to expand the expression in the denominator. Since the expression we're trying to find the limit of is in the form of a product, we can try to see what happens when we find the limit of each term separately. So since the expression is sine of x over x times negative sine of x over cosine x plus 1, we can try to see what happens when we take the limit as x approaches 0 of sine of x over x and the limit as x approaches 0 of negative sine of x over cosine x plus 1. The limit as x approaches 0 of sine of x over x is the fundamental trigonometric limit, and it equals 1. And I already made a video proving this result, as mentioned earlier. The limit as x approaches 0 of negative sine of x over cosine x plus 1 is just equal to negative 0 over 1 plus 1, because if we plug in 0 to negative sine of x, that's just negative 0, since sine of 0 is equal to 0. And since cosine of 0 is equal to 1, if we plug in 0 into the denominator, it just becomes 1 plus 1, and this entire expression just equals 0. So we can clearly see that both limits exist, which means that we can use the product rule of limits to conclude that the limit as x approaches 0 of sine of x over x times negative sine of x over cosine x plus 1 is equal to the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of negative sine of x over cosine x plus 1. This is equal to 1 times 0 if we plug in the values for these limits we just discussed, and this is just equal to 0. Therefore, the limit as x approaches 0 of cosine x minus 1 all over x is equal to 0.